Hello and welcome to our video on transformations of parabolas. Now you'll remember from our last video that the basic graph of a parabola has the equation y equals x squared. There's no other numbers, just x squared. And it looks like this. Smooth curve passing through the origin. It has a minimum, that's that point at the bottom, and the turning point is at the origin as well. What we're going to be looking at in this video is moving this curve around. So we might move it to the left or the right, or we might move it up and down. And there's a few other transformations we can do as well. And when we make these movements, it impacts on the equation, and that's what you need to focus on. I've got down here, there are 4 different types of transformations we're going to be looking at. The first one is vertical translations. So that would be the up and down one. The example I've got here is y equals x squared plus 3. So there's a plus 3 on the end. And here's an example of the graph. And if you compare that to the original graph, remember the original y equals x squared graph was down going through the origin. So when we put a plus 3 on the end, it moves the graph up to have a turning point going through plus 3. That's all we've done to the graph. If you had a minus, if it was x squared minus 3 for your equation, then the graph would move from the origin down to have a turning point down here at minus 3, and it would look something like that if the axis kept going. For each of these transformations, I'm going to give you a general equation that you can use for any number, and I'll be putting that in a red box. This is the general equation for vertical transformations. We use y equals x squared plus k. I've no idea why people have chosen k, but this is kind of like, remember when we look at linear, we have a general equation which is y equals mx plus c, and the m means something and the c means something. Well, in parabolas, the k means how far it's moved up or down. So here's your general formula, and the description says it moves the graph up or down by k units. We can't say k centimetres because it's just a graph. It's not centimetres. So we just say units. It means it moves it up or down on the graph. And it's called vertical translation. The second type of transformation is horizontal translation. So that's moving this way. An example. The example here I've got is y equals x minus 1 squared. With horizontal translations, it's really important that the x minus 1 is inside the brackets and then it's all squared. That's because it needs to be different to this one where it's not inside the brackets. So if the number's outside the brackets, it means it goes up and down by that number. If the number's inside the brackets, it means it's a horizontal translation. Now this one's a bit trickier than the first one because you need to think in opposites. So if you have a minus number here, it moves it to the right. So here's the graph I've drawn of x minus 1 all squared, and it's moved it over towards the right to have a turning point at x equals 1. I've put that down here. Our general equation is y equals x minus h. H is the letter we use for horizontal translations. All squared, make sure the brackets are there. And that moves the graph to the right, not k units. I need to change that. H units. Important that you put that it moves it to the right if it's negative. If this was positive, so x plus 2 all squared, I'll just write that out for you. Then you would move to the left, so it would go to minus 2. So it's just the opposite of the sign here. That's for horizontal translations. The third type of transformation is just positive or negative parabolas, and we saw these in the first video, but it is a type of transformation. So this is our base graph, y equals x squared, seen this one a few times now, and this is our negative graph, y equals negative x squared. So if the negative is in front of the x squared, it's a sad face, upside down negative parabola. The fourth type of transformation is called dilation, and that means how fat or skinny the graph is. So on both of these examples, I've put the graph of y equals x squared. It's this one here, and it's in blue, and I've labelled it. And here's y equals x squared again in blue and labelled. I'm going to start with the general formula for dilation, which is y equals a x squared. So it's the number in front of the x squared that will change, because there's two different options for dilation. The first one is if you have a fraction for your number a. So my example here is y equals a half x squared. And compared to the normal graph, y equals a half x squared is a fatter graph. So I've put this down here. If a is a fraction, then you get a fatter graph than the normal x squared graph. Our second example is if you have a whole number out the front of the x squared. So if a is a whole number, like 10x squared, or 100x squared, or 2x squared. Any number that's a whole number, this is your normal graph, and then this is your whole number for a. This is y equals 10x squared, and it is a thinner graph than the normal one. Turning point stays the same. Turning point doesn't move with either of these graphs. If a is a whole number, like 10, or 1, or 100, then you get a skinnier graph than the normal graph. We call a the dilation factor. That dilation just means fatter or skinnier with the graph. Once we know those four different types of transformations, we can actually put them together to do combination transformations. So one example I've put here for you has y equals x minus 1 all squared, which would move it to the right 1 unit. And then I have a plus 2 on the end, which would move it up 2 units. So we have the turning point there, and then you can draw the graph once you have the turning point locked in. And you can do any combination of the four transformations that I have shown you. This general equation will become really important for working out those transformations. This puts all of them together into one equation. So you need to make sure you copy this equation down. Y equals plus or minus a at the front of the brackets, x minus h all squared plus k. So we'll work backwards. The plus k on the end, if you remember, was the vertical translation, how much it moves up and down. The minus h inside the brackets is the horizontal translation, and it's the opposite of the sign. So remember, the minus means h units to the right. If it was plus, it would be to the left. The a out the front of the x squared is the dilation factor. And you need to check whether it's a fraction or a whole number to know whether it's a fatter or skinnier graph than normal. And the plus or minus sign out the front tells you whether it's a positive or a negative parabola, whether it's a happy face or a sad face. Thanks for watching the video today.